Good afternoon, everybody, and welcome to the Net Zero Technology Centre's Tech20. Tech20 is our social showcase for speakers presenting technology-focused topics in 20 minutes, and we are delighted that you have all been able to join us today for this webinar. Before we start, I have a few housekeeping rules for you all. Hopefully your microphone and camera have been automatically disabled for the duration of at least the presentation of the webinar. There will be a question and answer session after the presentation, which there are two ways you can ask a question. You can use the Q&A function, or if you feel comfortable speaking, please use the raise your hand function and we will be able to unmute you and you will be able to ask your questions. So you can get full enjoyment out of this. Please shut down any non-essential applications to avoid connection issues. And I guess we need to say that the webinar is being recorded, so there is no need to take snapshots or even try and record the webinar yourself, as this will be shared with you after the event. We call these Tech20 because we split them into 20-minute blocks. There is a 20-minute presentation from our speaker today, who I will introduce shortly. That is going to be followed by 20 minutes of Q&A. And then finally, there will be 20 minutes of networking for those of you that can stay online. So I guess comes to me I'd like to introduce our speaker for today. So John Hansen is a student of Earth Sciences, having a formative career in hydrocarbon field development. John went on to create his own geology consultancy, but moved across into the city after studying for a diploma in technical analysis. John has a keen interest in the energy transition and the nascent hydrogen economy, which he believes has a large gap that can be filled by natural hydrogen to decarbonize energy intensive industries. So I'd like to welcome John today, and I mean, don't give too much away about your talk, but can you just tell us a little bit about what you're going to talk today before you start, please?
Yes, I thank you for your introduction, kind words. I feel that as part of the energy transition, there's been a lot of focus on hydrogen economy with respect to anthropogenic hydrogen generation. And I feel that there's a big gap that certainly other countries are trying to exploit, which is trying to explore for natural hydrogen to try and get decent volumes and get a good supply of natural hydrogen to complement the existing anthropogenic hydrogen that's been created. So there's a boost to the hydrogen economy.
Okay, great. Well, we're going to be really interested to hear about that today in the next 20 minutes. So yeah, I'd like to hand the floor over to you if you're ready, and your 20 minutes starts now.
So as we all know, the UK government is trying to decarbonise the energy sector. And one of the themes in the energy transition is to try and introduce the hydrogen technologies to provide a hydrogen economy. This has been outlined in the hydrogen strategy in the Carbon Budget 6 and has been touted by many countries as well as the UK in COP26 recently. So from the slide that is on show at the moment, you'll see the large image on the left, which is supposed to represent the 10 to 30 terawatts of hydrogen that's produced in the UK currently. Most of that is grey hydrogen, but hopefully that will be turned into blue hydrogen when we have carbon sequestration and burial going on in about 6 to 8 years' time. We also additionally have a further 1 to 3 terawatts created by other chemical reactions as a byproduct, which may be used with the hydrogen technologies that we want to empower as part of the hydrogen economy. So power, for instance, transport, and other technologies. Additionally to that, you'll see a small photograph bottom right of the large picture, which is supposed to represent the 0.1 terawatts of green hydrogen that we produce currently. And if you can envisage it, there would be a further 10% of that picture covered up, which represents the 0.1 terawatts or 10 gigawatts of commitment that we've got for new capacity of green hydrogen by 2030 as part of our carbon budget 6. However, as you can see, if we're going to establish a hydrogen economy, we're looking to probably fill that entire picture with brand new green hydrogen. And as you can see, it's a very big process to tackle. So how can we speed it up? Well, one of the ways that other countries are looking at is to drill for hydrogen. There are several different ways that hydrogen can be generated within the Earth's crust. And this idea of being able to decarbonize some of the industries by utilizing some of this natural hydrogen has been touted at COP26. And the main thrust of that is to try and enlighten policymakers as to what natural hydrogen is, what it can do for the hydrogen economy. And as part of that, there's been a big discussion around the only hydrogen field in existence currently, which is the Brakabugu field in Mali, which is 98% pure hydrogen. And currently that is being developed by Hydroma, a Canadian company, and they're turning that into a mini energy hub, I believe, at the moment. So they're adding solar panels to it so they can create some anthropogenic hydrogen, use that field as a store for that hydrogen, and produce a mini array, a mini hub for energy. Next slide, please. One of the advantages that's been talked about with respect to this field and natural hydrogen in general is that when you compare it to the other forms of generation that man makes, because they're hitting thermodynamics in their processes for making hydrogen, they're quite expensive, especially when you compare it to the subsurface case in Mali, which is less than $1 a kilogram. Next slide, please. There are several processes that I've mentioned can generate hydrogen. In fact, there are probably 150 and rising. However, I just want to outline a few of the most well known. So, for example, in the top slide, you'll see the picture is focused on the Brakabugu field in Mali, which shows a typical fairy circle, which is the topographic surface expression of hydrogen reaching the surface and creating a natural structure that we can use as an exploration tool. Here, we've got iron 2 oxidation by water, converting it to iron 3, which releases hydrogen. Another method is by the similar reduction process, but using iron-rich formations such as the banded ironstones at the Fortescue Falls in Australia. Another method is that we believe that natural hydrogen is trapped within the Earth. So when the solar system was formed, hydrogen has been incorporated into the inner mantle and central core area, which is gradually being released. So we see this activity at plate margins. So, for example, you'll see these black smokers. Yet again, we also rely on the process of radiolysis, which produces not only helium, which we see numerous helium fields in North America and Canada, for example, but it also produces hydrogen as well. The problem with all of these generation methods is that they're in faraway places, away from areas of population and areas of demand. We have little to no data on these areas per se when we compare it to other areas of study. And so as a consequence, natural hydrogen is kind of being sidelined. It's thought to be too far away, too small, too niche. However, what if we could get over that? And I think the way that we potentially could get over that is by thinking of hydrogen generation as an organic process, as part of the hydrocarbon story. But it's strange that the hydrocarbon story currently doesn't mention any of this. We seem to have lots of hydrogen mentioned in terms of cracking oils down to gases within this story, but not really mentioned overall, and is not used as an exploration technique to guide us. Next slide, please. So this new idea that vast amounts of hydrogen could be created in sedimentary basins gets us around this idea of it being distal. We might be able to use existing infrastructure and existing ideas that we utilize for the oil and gas industry to exploit this. And it works in the same way that blue hydrogen does, in that methane at the end of the hydrocarbon process gets heated up, turned into organic hydrogen, and migrates and is trapped and is extracted. And the benefit of this is that you have natural sequestration. So the carbon is left behind, the hydrogen is free to migrate because it's a much smaller molecule. And so we potentially have a new idea to be able to look at, which might give us the volumes of hydrogen that we need in the areas that we want them, be able to utilize the existing infrastructure that's there. And it's a process that we're very familiar with and that we have lots of data on. But why has the natural hydrogen story never been discussed previously as part of this hydrocarbon story? Next slide. So when the hydrogen genesis models were put together to help exploration for oil and gas, you had the likes of Van Crevelin's initial thesis on this, and you'll see the picture on the left there. Different types of kerogen were heated up in a sedimentary basin, turned into oil, which eventually turned into gas, and then eventually there was nothing left for the process to create except graphite. Again, this is being reiterated in Tissot and Welt in 1984, and it's a basic concept that used to be taught at schools and used to be taught at universities. The end product of this, of course, seems to be graphite, which kind of is a bit of a head scratcher, if you will. If you've got a continuous scale of hydrogens going from long chain down to small chain, as Van Crevelin points out, then surely there must be a different endpoint. You can't make methane just turn into graphite. So if you click on to the next slide, please, which is kind of the idea that I'm trying to get across, which is the endpoint of the hydrocarbon process at the moment is an unbalanced equation. If you've got methane or dry gas created at the end of the hydrocarbon story, then when you heat that up, it must split and dissociate into something other than just carbon. Next slide, please. And we see from the existing model that that unbalanced equation has influenced the way that explorationists think about looking for oil and gas. Obviously, the focus has always been on the oil window, but you'll see that in the petroleum generation and conversion area, you've got the typical oil window, wet gas window, dry gas window. And then you'll see at the end of the dry gas window, you have dry gas preservation limit, beyond which methane no longer exists, and which graphite or carbon is generated instead. So the model that we've used for a long time to guide us on the oil and gas exploration front, unfortunately tells us that not a lot of hydrogen is produced. At the top of the standard maturation profile, you'll see that hydrogen is only thought to exist in the petroleum diagenesis area where you've got bacterial action. And then it doesn't play any part. At the end of the process, you'll see that only graphite is formed. And so we've come up with this exploration idea that there are over mature areas that we should not drill into because there's nothing there. It's a waste of time. This is why I think the unbalanced equation needs to be revisited. Next slide. If now we think of this simple equation and the end of the methane preservation limit as being a balanced equation, you'll see now we get the typical methane splitting into carbon and vast amounts of hydrogen. And this obviously will influence the generation story for hydrocarbon and also hopefully influence explorationists who think about an alternative method to go and explore for hydrogen in the ground too. Next slide, please. So a new concept is the idea that using a balanced equation now, at the end of the methane preservation limit, that would be maximum production of natural hydrogen. Prior to that, you'd have hydrogen being evolved and being preserved to some degree, but some of it is potentially used up in that dry gas preservation, dry gas generation window. Eventually, though, that hydrogen window will end once you get into the metamorphic area. This leads us to the idea that we're going to have a split in stages of petroleum evolution. We're going to have an area where we have petroleum catagenesis, where you get your normal oil, gas windows. Then you're going to have a metagenic hydrogas area. So this is where you're going to get natural methane and natural hydrogen produced together. So you might expect some areas for natural hydrocarbon generation to occur where there are also areas or formations that are filled with hydrogen as well as methane. And then you're going to get metamorphic hydrogen where only pure hydrogen exists. And hopefully we're able to find both of these areas because we could utilize metagenic hydrogas to use as heating. And obviously we could use the pure metamorphic hydrogen as a form of power or transportation. Next slide, please. But why are there no organic hydrogen fields now? Surely if I'm telling everybody that hydrogen is part of this hydrocarbon generation process, there would be lots and lots of serendipitous instances of natural hydrogen occurring. Well, this is all new to science, as it were. So organic hydrogen is new information. Consequently, as no one has really thought to look for natural hydrogen within the hydrocarbon generation sequence. We've always been told by science that hydrogen on its own, diatomic hydrogen, will not exist. It'll automatically and easily react with other elements, and so hydrogen will be taken out of the system, creating other molecules, and we won't find free hydrogen. The old hydrocarbon model implies that it's not worth looking post the methane generation window. And as a consequence, Big oil has only ever searched within the oil and gas window. That's their raison d'etre, if you like. And these over-mature areas have been left because they've always been thought of as barren. These underexplored deeper areas are ideal for hydrogen creation in the subsurface and a prime exploration target. But we've seen, if you read Zgonich's paper, for example, on this, you'll see that there are numerous natural hydrogen seeps that have already been discovered. So you have seen the Olympic flame in Turkey on Mount Kalamira, I think it is. And there are other natural seeps that have been discovered globally in association with organic hydrogen. So in the Canning Basin, for example, there are numerous hydrocarbon wells that have been drilled, and they have incidences of methane and hydrogen. There are places over in the United States that have hydrogen and methane occurring together. And even in the UK, coal bed methane prospectors, they find methane and hydrogen together. So we even have a small amount within the UK too. Numerous seeps are outlined in the Zgonich's paper, as I've said, but perhaps the biggest issue that we have for natural hydrogen, apart from science telling us that natural hydrogen can't exist as a free molecule in the subsurface, is the difficulty in detecting it. Next slide, please. So if we look at a normal rig nowadays, they have gas detectors on there, C1 to C8, to detect whether or not there is a methane leak, but there are no hydrogen detectors to tell us that hydrogen has come out of the borehole. And as a consequence, no hydrogen can be detected via that method currently. We also have gas detectors that we use during mud logging. These can detect hydrogen, but there is a disparity between whether or not that actually gets noted down in the mud log when you're in fact looking for methane or oil. Obviously, you don't want to put down any instances of hydrogen, especially as you're not expecting it to be there. Lastly, and sadly, the worst, I suppose, is that there's no standard agreed logging techniques to detect a column of free hydrogen in the subsurface, and hence there have been no serendipitous opportunities via this method so far. The reason being, I think, that logs have been discounted for natural hydrogen detection is that the view of most petrophysicists, particularly the ones that have worked on existing hydrogen fields, for example, tell us that resistivity for a free column of hydrogen in the subsurface shows up as a water-wet response. And the density neutron also shows up as a shell reading rather than a gas reading. And so you would probably, if you were using measurements while drilling, just blast through this particular reservoir thinking it was water wet rather than chock full of hydrogen. And you probably wouldn't detect it on your gas detector by the mud logger because he's looking for, or she's looking for, methane or oil. The best way to try and detect for hydrogen is using nuclear magnetic resonance logs. And here you're having to look at fast neutron cross sections and do detailed analysis on that to try and work out the algorithms that you need to determine the substrate, lithologies, and also the fluids that are contained there. Next slide, please. So now that we think we can generate hydrogen, we understand how a deficit in how we detect it. How do we go about understanding how it migrates and how it's trapped? So as you can see from this diagram, we have this idea that hydrogen, being a small atom, can easily migrate. And the animation, the GIF that you can see is trying to demonstrate the Grosshaus mechanism, whereby you've got proton hopping. So here you've got a proton hopping between the different water molecules that you see there. So this creates what's known as a hydronium complex, which is formed when hydrogen reacts with water, is dissolved and splits, producing a free proton that can hop between different molecules within the fluids. And so, as you can see, we've got small hydrogen molecules, and we've also got this idea of proton hopping, which means that perhaps migration probably isn't an issue. However, trapping might well be. Next slide, please. As there are numerous seeps and small accumulations that have been observed globally, there must be some sort of trapping mechanism. And one of these ideas is that there is so much hydrogen produced that you're producing a hydrogen flux. So even if you have a leaky reservoir and you're producing these fairy circles at the surface that show that the reservoir is leaking, then because you've got constant generation of hydrogen, and such a high volume of it, then you're still going to have sufficient in the reservoir to go and extract. Also, you're also going to have the normal methods of trapping that you associate with oil and gas research and all of the prospects that they generate. But of course, the best seal that there is probably salt or igneous injections like you've got in Mali that form good seals. But to reiterate once again, I believe that the evidence of all of these seeps show that there is sufficient trapping going on for us to warrant exploration. There's a third idea in this as well in terms of trapping, and that is that like in the Permian Basin in the States, where you've got methane trapped in small microstructures in the shale, this may well also be true for hydrogen. Next slide. But how can this whole idea of natural hydrogen help the energy transition and the hydrogen economy? Well, I think it's something that should be used in conjunction with the existing anthropogenic hydrogen generation and the other energy transition techniques, much in the same way that they're doing at Barakabugu in Mali, and create these small microgrids. So, for example, why bother storing hydrogen in a massive, expensive cylinder or a man-made cavern when you simply reuse the existing natural hydrogen reservoir that you're producing, which already will contain cushion gas of hydrogen, so there's no need to pre-fill it. So work with nature rather than against it, and work with the anthropogenic methods for hydrogen generation and for energy production. Another area of concern, I guess, for natural hydrogen is that because there are so many methods to generate it, you're essentially de-risking when you're drilling. So, for example, you might see that rather than just organic hydrogen potential in particular prospect, there might also be radiolysis potential. There might be also potential from the outgassing from deep structures. So you're essentially de-risking the whole hydrogen exploration chain. Because of these, you may think that sort of rather than just going for organics, you might want to go for banded ironstone formations as well. But also that there's the concept that you might not just be going for natural hydrogen. Hydrogen also occurs with helium. You might also strike one of the largest lithium brines when you're drilling as well. And so this holistic approach to looking for natural hydrogen needs to be taken into account. So for example, when we try and make hydrogen useful, like in the lime kiln test over in the Peak District, where you had the Tarmax lime kilns, rather than using anthropogenic hydrogen, perhaps you could use natural hydrogen instead as a source. Next slide, please. So, for example, following on from the Barakabuga example of creating a micro grid, perhaps the setup might be something like we got in this picture, which is a closed system combined heat and power unit, which generates electricity. Any excess electricity is used to create natural hydrogen. And then in lull times or at night time, when we need that energy, we can either extract it from the anthropogenic natural hydrogen that we've injected, or use the natural hydrogen that is already there to fill in the gaps. And I think that would produce a win-win for local economies as well as the grid, and essentially de-bottleneck this north-south divide for the grid that we've got currently. Next slide. And of course, we're gifted in the UK because of the many different geological themes that we have existing. So we have cratonic plays in the north, for example. We have tertiary volcanics, which give us these injections of dolerite sills that we could go and explore for. We've got these anthracitic coals and people who are looking for coal bed methane, and perhaps this idea of organic hydrogen might be able to help them explore better to look for natural hydrogen. Of course, we've got serpentinization down in Devon, and obviously we've got the associated volcanics for radiolysis over in Cornwall and in other areas of the UK too. And we've got vast areas of subsalt that exist for a good trap. But also we've got down the bottom, deep primordial outgassing. So you'll understand that you have the Variscan orogeny, and that calls the wheeled fall belt. But you've got the tip outs of the large faults that occur in Devon and Cornwall, and also in the mid-North Sea there. It's of interest to note that you have something called the Fizzy Field in the North Sea there, which seems to be sitting right over the top of one of these deep structures that accesses, I think, this deeper sort of play. Hopefully you'll agree that natural hydrogen is able to complement the existing anthropogenic effort that we've got for the hydrogen economy so far. Thank you for listening. And now I'll pass you over to Ian, and we'll start the Q&A session.
Well, thank you very much, John. I hope everyone found that as interesting as I did. Yeah, so remind people, please, to use the Q&A box to ask any questions, or say if you'd like to ask your question in person, please raise your hand while people are... Okay. We've got one straight in. Great. It's from Alice saying thanks for bringing this topic to Tech20. I think native hydrogen is a very exciting area. As a recent ex-petrophysicist myself, I have a few questions. Have you seen any examples of successful interpretation of native hydrogen using NMR?
Yeah, I've spoken to Dennis Briere, who is the petrophysicist that's done all of the work on the Barakabuga field in Mali. And so there are some examples of his interpretations on there, because it's a set of lithologies that we're not used to. I mixed dolerites, some metamorphized rocks, some natural aquifers in there as well. There it's not something that we're familiar with. We're used to looking at something that's either clastic in form or else something that's limestone in form. But he and his good friend Ross Crane, it's worth looking at Ross Crane's website on this. He outlines what he feels is the best method to try and attack this conundrum with. And I understand that also there's going to be a petrophysical conference on natural hydrogen sometime in 2023, I think. So that would be somewhere to talk about that. But I think that the main thing that Dennis said when I asked him the question, if you have free hydrogen in a classic reservoir, would it show as being water wet? His idea, he said, most definitely yes, and that's why we haven't detected it so far. Because I can't stress enough that obviously there's a lot of work that needs to be done by the likes of Schlumberger and Baker Hughes on this. But whether or not they bring it out from under their bushel and give it the light that it is needed so that everybody can explore on a level playing field and we can get hydrogen economy sooner. I don't know whether that will happen. Hopefully it will. The other thing to say is that they mentioned that this idea of hydrogen dissolving in water to produce this hydronium complex is very similar to the idea of salt. So sodium chloride splitting up into its constituent anion and cation and producing that low resistivity. In the same way, it's thought the hydronium complex does that for us. Hence its low resistivity and looks water wet.
Okay, great. Thanks, John. I hope that answered the question. Okay, Alice is keen to ask another question, but I've got another one coming in first before Alice was going to ask. This is from Molly. Thanks for the presentation. I'm interested to hear what kind of technology equipment would be required in the extraction of native hydrogen and related processes.
It's exactly the same set of processes and same equipment that you'd use for oil and gas, which to my mind is good. If you're trying to get the oil and gas industry weaned off of looking for hydrocarbons, the good way of doing that is say you can use all of your equipment and all of your skills to go and look for hydrogen instead in the subsurface. You just drill using a standard oil and gas drilling rig. You extract it in the same way to a wellhead, and then I don't want to get into a big debate whether or not you want to use this in distal areas and transport it through kilometers of pipeline. I'll leave that to the engineers to argue about, because there's still this big argument about whether or not hydrogen attacks the metals that we use for existing pipelines and so would fracture them. But essentially there's not too much to change. Might have to change a few sort of rubber components on drilling rigs. You might want to have optical scanners on the rig floor so they can detect hydrogen leaks, but everything's doable. And the good thing is that it doesn't interfere with the anthropogenic hydrogen process that we're going through at the moment. And so the two things can run in conjunction and not interfere with each other. Potentially also we could use infrastructure that is existing currently.
Okay, great. Thank you very much, John. So we've got Alice wants to come online with another question, and is actually going to ask this one in person. So that's really great. So if we can, there you go. You're unmuted, Alice. Far away.
Thanks, Ian. Hi, John. It's more of a comment. I was recently at an EAGE meeting a couple of months ago in Paris. There's a lot of work happening in France around native hydrogen. I don't have my notes on me, but yeah, the question about NMR is certainly interesting. I don't have a particular question. It's just that there's a lot happening, and I think the UK can certainly look to other places like Mali and France, because what we're going to need going forward is a mix, and this can certainly be part of it, I believe.
Yep, there's a big centre for native or natural hydrogen in Pau in France. So the key speaker, the lady that spoke at COP26, for example, I believe she is a current professor there or was a professor there. And she's involved, I think, with the IEA, Hydrogen Europe, the Pau University, and spread the word as a convener as well at the Natural Hydrogen Conference too that occurred in June this year. So there's a lot of activity in France. So you've got 458 Energy, for example, a natural hydrogen company there who's doing a lot of work with Total Energies. They're looking at the Massif Central region, I believe. We have our own as well. We have Helios. They're run by a couple of professors out of Durham and Cambridge. I think it's John Glewis and Peter Ballantyne out of Cambridge. They have Helios. They're looking in Spain. They try to look in the UK, but the UK government doesn't seem to want to engage just yet. I don't know what the problem is within the UK. Might be an expertise thing, I don't know. But certainly France is streets ahead. There's also a lot of activity in America. I'm talking to the Department of Energy in America, as well as the key writer of their natural hydrogen thesis for the USGS, Jeffrey Ellis. So there's lots of activity in the States. They're producing subsurface hydrogen by setting fire, essentially, to old coal fields or old hydrocarbon fields, and sequestrating the hydrogen in the subsurface as sequestrating the carbon in the subsurface as the hydrogen is produced, so that you essentially have clean hydrogen produced and coming out of that. If you note, in Australia, they did a similar process, and that formed the first shipment of natural hydrogen to Japan. So it took 16 days to travel on the back of a ship. I don't know what the particular compression ratios were or anything to do with the hydrogen that they shipped out there, but obviously the boil off on that is a heavily guarded secret. There's lots of activity in Canada. You have, as well as Hydroma being based there, you have Natural Hydrogen Energy, I think, is based in Nebraska. And you have Hyterra, their joint venture partner, which have just listed on the Australian Stock Exchange. So there's a lot of activity everywhere globally: Africa, Brazil, Morocco, Algeria, Mali, all over the planet, just not the UK.
That's interesting. I was going to follow up on that. So, the last slide you showed there about, potential areas within the UK, obviously that's actually all onshore.
Yeah.
And, I guess that would be going back to sort of, I guess, more traditional methods of extracting natural hydrogen compared to the sort of the rebalancing of the maturation equation. I mean, is there a hesitancy in onshore? I mean, is there potential, the word fracking comes to mind. Would you need to do that to produce, and would that be an issue?
I think that because the hydrogen molecule is so small, there's potential to get away without fracking. Mm-hmm. But also, the reason I've highlighted just onshore areas is then you've got this idea of being able to create and marry it up to existing anthropogenic hydrogen and the efforts that are going on for the energy transition so far, so that you could then produce microgrids. So Protein, for example, has a big drive for anthropogenic hydrogen in Teesside. They're just expanding that yet again. Good to them. But maybe the natural hydrogen people could work the other end of the problem, and perhaps something in Weardale or Teesdale or on the top of the Pennines there could produce hydrogen and have a localized smaller grid to alleviate the issues of this idea of bottlenecking that we have within this whole energy transition. So you create these micro areas onshore that act as your genesis for microgrids. And as well as diversifying the grid, you then build up the local economy, you level up different areas of the UK by having these microgrids. Villages don't die, they expand, the schools have more pupils in them, etc. So that's why it's kind of, the focus has been shown to be onshore. Obviously, there are areas to look at offshore and heaps of data to go through too. So I'm not discounting any of the offshore. It's just that obviously the BGS needs to get involved with this, as well as BICE, from an industry standpoint, so that they can set policy and have an idea of how big or small or niche this area is, and come up with some sort of policy ideas. I think this is probably a good starting point.
Yes, I mean, agreed. I guess, we've got to look at every opportunity in the energy transition, and why not this, so yeah, let's hope it can be progressed. I guess I'll open this up. Are there any more questions coming through? If there isn't any, I would like to say thank you very much to John, and we will open up the session for networking for those of you that can stay online for another 10 minutes or so.
I have a question. I'm not sure how this works. Is that okay?
You're coming through loud and clear.
Fire away, Alice.
Excuse my ignorance, John. But are there any kind of startup companies that might need a bit more of a platform? That, I mean, that's a big part of what the centre, is able to provide, given the right R&D opportunity.
Yeah, I think that there is an opportunity for a platform to be developed. I noticed that the Geological Society are going to have their first conference on natural hydrogen in 2023 in the summer. And so they've got a call out for papers in that currently. And I'm presenting in December on the 15th, I think, for the PSGB on a similar sort of theme. And so hopefully there then gets to be a groundswell or a subsection perhaps of the PSGB that's specifically focused on natural hydrogen, or perhaps the Geological Society that has a niche area for natural hydrogen within it. I'm all ears. I know that the Hydrogen UK, the people there, they're a bit tentative on this because they don't want to deflect the existing goodwill that they have from government associated with anthropogenic hydrogen being sort of contaminated in some way by people talking about natural hydrogen, which I think they think might somehow deflect from their own work. I don't know. Maybe I'm getting that read all wrong.
Okay, I think that's a shame, and maybe shows a bit of a lack of context and understanding, perhaps, but I don't know.
Yeah, you might be right, Alice. But as you know, politics has a timeline horizon of about a week at best, and if you're lucky, the full term of a parliament over 5 years, and then things can dramatically change, as we've seen. And
also, I mean, we've had a much more of a groundswell recently with geothermal in the UK. So, you know, there is certainly a pipeline there. Just talking about it and making it part of the conversation.
And I think natural hydrogen could really complement geothermal drilling going on. So say, for example, you had a multi-stack prospect there that might be looking for either lithium, helium, natural hydrogen, but all of those fail. You then just turn it into a geothermal project. You recoup perhaps your capital costs that you spent, perhaps at a lower rate, but it's still not a loss. You know, so this idea of de-risking things comes full cycle, if you like.
Yeah,
and that's what I mean by combining all of these things together. Obviously, it takes a bit more preparation. You're looking for 5 or 10 things now, not just one. You're not just looking for hydrocarbons and a big booming sort of response of resistivity to look out for. You're looking for, you know, is there a lot of lithium in the particular brines that you're going through? Do we have the benefit of having 3 different things there? So, for example, do we have helium and hydrogen together? Plus, we've got lithium. Which one did we develop first? And then at the end, do we turn it into geothermal energy as a power source? And at the end of that, then also have a series of governmental spas. So a new set of spa complexes developed throughout the Pennines, for example, on the back of this in 20 or 30 years' time, where you don't just go to Bath to take the waters, you go to the top of Kilhope or something like that in Weardale, and you take the waters at Weardale. And again, you then bring in this idea of new places to go within the UK to have enjoyment, new centres of economy that have been developed in rural areas. People have jobs, people, you know, give buy-in essentially to generating energy. So there's a lot to think about. And, you know, Tom Baxter is great at this at Strathclyde University, of thinking out of the box and having this holistic approach. And I think this holistic multi sort of phase approach is something that we need to seriously consider.
Yeah, you go on. I guess should open up Sergio and Willie. Thank you for staying on. Do you have anything you want to ask, discuss with John? If not, I was going to sort of ask about obviously you've mentioned the Mali field and other people who are looking into produce or looking at the opportunity around natural hydrogen. Is there anywhere else in the world that's sort of actively exploring or producing?
Brazil is really big on this at the moment. Mm-hmm. They've got lots of occurrences of fairy circles that they see, that they're trying to quantify how much hydrogen is associated with those, and how deep those basins are, how easy it would be to explore and get that hydrogen or that energy out. As well, you have the African Energy Confederation, I think it is. Basically, there are a lot of African countries that are looking into hydrogen. Their idea is that it's something, because of the engineering problems associated with it, might be considered more local rather than global. So it's a local economy thing. And again, they're on about developing this idea of microgrids and using those to essentially bring hydrogen to what is rural areas in many places and stimulate growth that way.
So how do they, I mean, maybe I'm getting my wires mixed up here, but, you know, I guess, you know, when we're talking about the organic hydrogen and, you know, the detection problem
Yes.
of it, how do you go about exploring for something that you can't detect? Is it like, you know, a lot of these, like,
It's
sort of like the Mali thing, is that more of a visual thing where you see the sort of pot marks or holes?
it's simply a case of oversight. I think you can detect natural hydrogen using the gas detectors that we have on rigs currently for mud logging. So it appears as what would be like a hotspot, I think it's called. I'm not entirely certain. So you can use those to detect for natural hydrogen. But I think that Helios, for example, have developed handheld detectors that have sent some of their PhD students out into the hillsides of Spain in Aragon to actually detect the leakage of hydrogen through the subsurface. So this idea of fairy circles that you see, and you'll see that on, I think it's slide 3, that there is a count of hydrogen as you progress out of the center of the fairy circle, detecting natural hydrogen at the surface. So there are surface detectors, just they're not widely talked about at the moment. And that is a legacy of science thinking that hydrogen doesn't exist as an element on its own right. It usually bonds with something else. But now that people are searching for it and thinking about it deeply, these hydrogen detectors are going to get more numerous, more advanced. But they do exist. People are working out in the field with them at the moment.
Wow.
I guess NMR as well.
Yes, I was speaking to Dr. Niels Kragen-Low over at Baker Hughes, and I was saying, have you got something like this? You're aware of these things, I presume. He's like, oh yes, we're aware. We're aware, don't you worry. But what they are and how they think they work and when they're going to bring it to market, I don't know. I presume it's going to be this idea of fast neutron cross sections and advanced algorithms associated with all of these things, but I don't know. I don't know whether or not you'll be able to reprocess old logs so that you'll be able to rescan old neutron logs with these new algorithms that'll then show up as hydrogen rather than being water wet. Who knows?
That's a good idea.
It's open
The data's
territory.
there.
There's a lot of data to go through. If you can automate that process, then obviously you're onto a winner.
Yeah. Great. Well, plenty of opportunities, I guess. You know, I guess someone's just got to, yeah, get behind it, I suppose, isn't it? It just needs
Yes,
tracking,
exactly. The conditions need to be right.
Sort of,
Otherwise,
yeah. I've tried reaching out to Paul Monks and several of the other advisors for the government and obviously BICE and people like that, but it will come eventually. It's just going to take time for them to sort of be alerted to it, I think.
I have one quick question, if that's all right, Ian.
Yep.
yeah.
John, what piqued your interest in native hydrogen? When did you start working on this?
I started working on this during the COVID problem, and it scared me, the numbers that were coming out from green hydrogen, this idea of we're going to have to give up oil and gas, and one of the options is to use green hydrogen for power and heating. I thought, how the hell is my poor father going to heat his house with prices like that? There must be a cheaper way. And that led me on to then trying to understand about blue hydrogen and steam reformation. And then that led on to the idea of dissociation of methane onshore as well. And that being producing no carbon dioxide, because you're splitting the methane into purely carbon and purely hydrogen using some sort of catalysts. And then I thought, well, hang on a sec, don't we already do this? Surely Mother Nature must split methane somehow into its constituent parts, especially if you think of the analogy of something like the Frigg field being buried deep. So you've got a classic reservoir, pure methane. What happens when that gets buried deep? Surely at some point it must go through the same thing. And so then I looked at how you produce oil from shale and shale oil and how that's created. And then, of course, you get to the idea of Fischer-Tropsch. The Fischer-Tropsch process being essentially this process in reverse. So you start off with carbon, you add hydrogen to it, you produce some sort of liquids that you then turn into oil. So that was developed by Germany in the Second World War and has been a large-scale process in South Africa. And then once you mix all those ideas and, you know, a couple of cups of tea and hey presto, you think, well, there's something in this, I'll have to think about it further. And that's how it came about.
Thank you.
Cool. Right. Well, I think that brings us nicely to spot on the hour. That's really great. Must admit, I don't know what happens now.
We'll just hang up.
Being the first webinar one we've hosted, well, I've hosted, and the networking bit. But I guess, yeah, we say
Go
thank
and
you
have
very
lunch.
much. Yeah, go and have some lunch. So thank you very much, John.
You're welcome.
Thank you, John.
Thanks for having me.
Yeah, well, thank you, and everyone enjoy the rest of their weekend.